So the next thing we're going to learn about is Hooke's law, which is basically a spring force when an object is compressed against a spring or stretched away from a spring. So our units for force, once again, are newtons. Our units for K, spring constant, are newtons over meters. And our units for delta X, which is the displacement, is meters. So our first example, a 0.4 meter spring is stretched to 0.5 meters by a 15 Newton force. What is the spring constant? So let's go ahead and list our givens. We have delta X. Oops. Delta X is equal to, it's a 0.4 meter spring, it's stretched to 0.5, so its displacement is 0.5 minus 0.4, so we get 0.1. By a 15 Newton force. So our spring force is equal to 15 newtons. We want to know what is K, the spring constant. So our equation is F equals K delta X. Plug in our, solve for X first. Solve for K first, so divide by delta X on both sides. Divide by delta X. You're left with K is equal to force over delta X, which is equal to 15 newtons divided by our 0.1 meters. And you get a spring constant of 150 Newton over meters. So what force is required to compress a 20 centimeter spring to half its length? Okay, so that tells us delta X. Delta X, it's going to half its length, and its length is 20, so it is being compressed 10 centimeters. So 0.1 meters. Our spring constant K is 170 Newton over meters, and we want to know force. Okay, so force is equal to K delta X. Plug in our givens. We have 170 times 0.1. So you get a force of 17 newtons. Okay, so for our next problem, we have a spring that is 0.1 meters long. And when a mass is connected to it, a 5 kilogram mass, it stretches to 0.015 meters long. .15 meters. Okay. So what is the spring constant K of this spring? So in order to be able to do this problem, we need to know what the force is. We can see in the problem that we're only given the delta X. We want to know K, so that means we must know what the force is. So if you look at this picture, we can draw a free body diagram for this picture. We know that the spring force upward, when it's in equilibrium, is equivalent to the force of gravity downward. So let's go ahead and write an equation that tells us this. So sum of the forces in the y direction are equal to force of spring minus force of gravity, which equals ma. And in this case, when it's in equilibrium, acceleration is 0. So we have spring force is equal to force of gravity. And we all know that force of gravity is just mass times gravity. Okay, so when we get to our equation, our spring force is equal to Kx, K delta X. Well, we don't know what K is, so let's go ahead and solve for that. So we want to divide by delta X on both sides. We want to divide by delta X on both sides, so we end up getting K is equal to F over delta X. And in our force in this case, we just said it was equal to mg, so mass times gravity divided by delta x. And we plug in our givens, we get mass is 5, gravity is 9.8, and delta x, how much it was stretched by, well, that's 0.15 minus 0.1, which gives us a value of 0.05 meters. Plug that in your calculator and you should get K is equal to 980 Newton over meters. So at this point in the video, you should probably be pausing whenever you see a practice problem. So pause the video now and go ahead and try the problem by yourself, and then watch the video to check your answer. Okay, so for this problem, we can see that a large spring has an equilibrium length of 3, and it is being compressed to 2.5 meters. That must mean its delta x is equal to 0.5 meters. Okay, our K value, it says the spring constant is 500, so K is equal to 500 Newton over meters. What is the magnitude and direction of the spring force? So F of S is our unknown. Let's go ahead and plug in. F of S is equal to K delta X, and we get 500 times 0.5. Well, half of 500 is 250, so our answer is 250 newtons. So now we can narrow our answer choice down to either B or D. So in order to figure out whether it's left or right, you have to go back to the original picture. Basically, once you compressed it or stretched it, what is the box going to want to do if you let go of it? Well, in the bottom picture right here, if we let go of that box, it's going to want to move to the right. So that must mean our direction is to the right. So B would be the correct answer here. A spring has a spring constant K of 50 Newton over meters. How far will it stretch if a 6 kilogram mass is suspended from it? So this is similar to example problem number 3. So go ahead and pause the video now and try it on your own. So a spring has a spring constant K of 50 Newton over meters. How far will it stretch a 6 kilogram mass? So here is our tightly bound spring. Then when the mass is added to it, it stretches delta X. So our delta X is our unknown. We know that our K value is equal to 50 Newton over meters. And in order to find delta X, that must mean we know the spring force. So let's go ahead and find the spring force. According to the free body diagram, the spring force upward is equal to force of gravity down. So our force of spring is equal to mass times gravity, which is just equal to 6 times 9.8. Okay, so let's write our equation. F of S is equal to K delta X. And when we solve for delta X, you get spring force is over, this is supposed to be a K. Delta X is equal to spring force over K, which gives us 6 times 9.8 divided by 50. When you plug this in your calculator, you should get a delta X of 1.176. Let's go ahead and round it. So 1.18 meters.